Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will be going over a homework problem from section 4.2. This is question number 3. It says that we suppose that we're offered the following deal. You roll a 6-sided die. If you roll a 6, you get $17. If you roll a 2, 3, 4, or 5, you win $3. Otherwise, you have to pay $2. Now they want us to complete a probability distribution table where we list the X values, and X is the profit, and they want us to do this from smallest to largest. Round to 4 decimal places when appropriate. Okay, so let's get started with the idea of the scenarios that were happening. So let's label this as an event. Roll a 6, roll 2, 3, 4, or 5, and then the only thing that would be left would be rolling a 1. So those are the 3 possible events. Now out of these events, we want to know what our random variable X is. Now the random variable X is the profit that we get. So we're not talking about the number 6 or the number 2, 3, 4, or 5 or the number 1. We're talking about the profit for your random variable. So the profit that you get if you roll a 6 is going to be $17. So that's going to be the first X value. If you roll a 2, 3, 4, or 5, you're going to get $3. And if you roll a 1, then you're going to lose $2. So the losing $2 will be denoted by a -2. And then at this point, we want to find probabilities. And that's how we're going to be able to attach the probability with the random variable. What is the probability that we get 6? In a 6-sided die, we get a 6. There's 1 out of 6 possible choices. 2, 3, 4, or 5, there's 4 out of 6 possible choices. And a -2, there's only 1, because that's rolling a 1. There's only 1 out of 6 possible choices. So these are probabilities. Now, I think in the homework, they want us to put in the values. So this is going to be 0.166, and then we round off to 7. And this is 0.6667, and this is 0.1667 again. So those should be our solutions. They want us to go from smallest to largest, so the smallest value is -2 with a probability of 0.1667, and then 3 with a probability of 6667, and then $17 with a probability of 1667. Okay. So that's our table. One thing to note about the table is that if this is in fact a probability distribution, we would add this up and we should get 1. So encouraging you to use some sort of spreadsheet. I have this set up, and I'm going to put my X values -2, 3, and 17, and my P of X values. Now I can put these numbers in. That would be 0.1667, 0.6667, and 0.1667. Now, because we're rounding off, and all of these things we ended up rounding up, when we take the sum of these values, we're going to get something that's slightly bigger than 1. So I think the homework system accepts this. So I think it's okay. But in general, we want to make sure that we're putting in values that are actually equal to 1. Okay, and since we do have this sort of technology, it might be good to actually put in the fraction. Now, when you put in a fraction, make sure you press equals in your technology, in your Excel or your Google Sheets, because if you don't, it's going to say 1 divided by 6, or 1/6 will be a date, and it'll look at it as January 6th, which you know, we want it to be a fraction. So putting an equal sign, 1 divided by 6, and we get something that's more exact. And then equals 4 divided by 6, and then equals 1 divided by 6. Oops, I went negative here. Let's undo that. And let's start off by saying equals, and then 1 divided by 6. So now you get 1 exactly, because our system is a little bit more precise here. Okay, so now that we have that, our next question is find the expected profit. So this is your expected value. So the formula for expected value, if you remember, looks something like this. Formula is actually, the expected value is actually the mean. So you can call it E for expected value, or you can call it mu, because that's really what it is. And this is going to be the sum of x times p of x. So you find all the x's, multiply it with p of x, and then add them all up. So if you're doing this by hand, which again I don't suggest, you would put x times p of x here, and then you get values for these things, and then you would add them all up. So you'd add up the values that you get from here, and then that would be your expected profit. So with Excel or with something like a Google Sheets program, that's going to be quite easy to do. So we will have in our next column x times p of x, and then all we have to do is say equals, and then we'll say x and then times, so that's shift 8, and then p of x, I'll click on p of x, and then I will get this value. It's negative 0.333, etc. Now for this, I think they're starting to get fancy and do autofill. You can just say check on the autofill, yes, because that's what's going to happen, or you can take this, click and drag, instead of redoing everything over again. So these are the values that you would have if you were to multiply negative 2 times 1/6, 3 times 4/6, and 17 times 1/6. And then you're also going to want the sum of this, and this is going to be your value that you're looking for. So I'll say equals the sum, parentheses. It looks like they've already highlighted this, pre-highlighted this for us, but you can also click and drag to make sure that we're getting the same thing. And we get 4.5. So $4.50 is what we have. So the expected profit here is going to be $4.50, rounding off to the nearest cent. So interpret your expected value. Expected value, you win this much if you play the game. That's not really a guarantee, because you roll the dice, you roll the die, and then it could be whatever it is. So that's number 1 is not a good answer. Number 2, this is most likely amount of money you will win. That's not so accurate either, because it's not likely in the long run. The last one, if you play many games, you will likely win on average very close to 450. So that is more of a more accurate interpretation of the expected value. So it's going to be, this is going to be the response. And then finally, based on the expected value, should you play this game? Well, before looking at any of the choices, I'm seeing this is a game. You could possibly lose $2, or you could possibly win $17, or possibly win $3. So winning or losing the amount, these individual amounts, is not really that telling in terms of the long run of the game. But if your expected value is at all positive, in this case it's positive 450, then this is probably going to be a good game for you. Now, if it's a negative number, regardless of how small the negative number is, in the long run, you're going to be expected to lose that much money for every game that you play. But here, you're going to be expected to win $4.50. You know, as they state here, if you play the game many games, you will likely win on the average very close to $4.50 per game. So that is what we're looking at. And since you're winning instead of losing, that's probably a good game. So let's see. I would not do the no's. It's a yes. Yes, since the expected value is 0. Well, the expected value is not 0, so we can move on. Yes, because you can win $17, which is greater than $2 that you can lose. So that's not quite the telling story. I mean, you could win $17 or you could lose $2, but the telling story is what happens in the long run, and that's the expected value. So the last one, yes, since the expected value is positive, you would be very likely to come home with more money than you had played the game if you played the game many times. So that, I think, is the response. In the long run, you'll be winning something because we have a positive expected value instead of losing something. All right, that is this problem, and I hope this will help. Good luck.